For now, we have the camera set up, and the background is attached to the camera, so it looks like the background is static. In this lecture, we are going to add the parallax effect to the two tree layers in the background. And we are going to do this by creating a special material for the background layers. Let's bring up the content drawer. Let's create a new folder under the game folder. I'm going to call the new folder Materials. Let's get into the folder. Right-click and create a new material. For the name of the material, Parallax BG material. Alright, we have the material file here. Before we do anything, let's save the file first. Now we can open the material. I'm going to dock this window to the editor. What we have here is the default material that is for the 3D game environment. So the first thing we need to do here is to change the settings to make this material work for our 2D game. Go to the details panel on the left. Let's change the blend mode from opaque to masked. Then we need to change the shading model from default lit to unlit. In the default lit model, the material is going to be affected by the lighting. But in our 2D game, we don't need any light sources. That's why we have to go with the unlit option here. And you're going to notice that once we select the unlit, some of the inputs on the material become disabled because the material is not affected by light anymore. So we don't need those inputs. And the emissive color input is going to determine how the material looks. It's like the material is glowing by itself, so it doesn't need any light sources. Next, we need to enable two-sided. This is going to make sure that when the player is rotated, we can still see the material. Otherwise, you are not going to see anything when the back side of the sprite is facing you. Alright, the setup is finished. And for the remaining inputs we have here, we only need to use the emissive color and the opacity mask. First, let's add a node called Sprite Texture Sampler. This node represents the sprite file we assign to the sprite component or the flipbook component. For now, we can only see the default texture the engine gives us. This texture doesn't really matter. Let's just ignore it. Let's connect the RGB output to the emissive color input. This is going to make the material display the sprite file. Let's also connect the alpha output to the opacity mask input. This makes sure the transparent pixels of the sprite file is displayed correctly. Down here on the left side, you can see the sprite texture. This is only for the preview purpose. When you assign this material to a sprite or a flipbook, the material is going to display the sprite file. So this preview texture doesn't really matter. But if you want, you can change it to any texture that comes with the engine. These texture files are in the engine folder. For example, you can search for Paper 2D or Sprite. You can use this dummy sprite texture. It comes with the engine to help us preview 2D materials. Alright, now you can see the material is displaying this texture file. So basically, what we have now is a basic material for the sprite. To create the parallax effect, we can animate the UV of the material to make it look like the sprite is shifting horizontally. Let me show you how to do it. We add a node called camera position WS. So this represents the position of the camera in the world. We use the split components node to break the data into 3 channels. Because to make the sprite shift horizontally, we only need the X channel. Then we multiply it by a very small number. This is because the X location is pretty big for the UV of the material to work with. So we multiply it by 0.00005. Then we call the append node, because the UV of the material expects a 2D vector. So this append node is going to help us create a 2D vector with 2 inputs. For the B input, we just plug in the blue channel of the camera position. This is going to be the vertical position of the camera in the world. Now we have the vector2 data ready. It's going to shift the UV of the material based on the camera's world position. That is going to make it look like the sprite is shifting, even though the sprite component is not actually moving. It's just the UV of the material is shifting. So now we need to add this vector to the UV to create the shift. So we do need the UV of the material. We can search for the texture coordinate node. This node is the UV of the texture. A little bit more on the concept of UV. This is a very common concept across the CGI industry. If you have any experience with Blender, where you can create some models and the textures, or maybe you have some experience creating materials in any game engines, then you should be pretty familiar with this concept. Otherwise, it does take a lot to understand how it works. You can just think about the UV as a 2D coordinate that tells the engine how to display a texture on the surface of a 2D or 3D object. UV is a 2D plane. U represents the horizontal direction and V represents the vertical direction. This is even true for 3D objects, because in that case, we unwrap and project the surface of a 3D object onto a 2D plane. If you really have a hard time wrapping your head around the concept of UV, it's completely okay, just relax, because UV is not a core part of this course. And you can just follow the steps here, and the parallax effect is going to work for you. And you are going to understand this idea as you spend more time creating video games or modeling 3D objects. All right, let's go back to the material. And we just use the add node to add the vector and the UV together. This is going to create a new UV. Then we plug in this new UV into the UV input of the source texture node. We can see in the preview window, the texture changes as we change the position of the camera. Alright, this is the basic setup. Let's hit the apply button in the upper left corner. This is going to apply all of the changes we just did to this material. Let's go back to the BP background to assign the material. But we do not want to assign this material to the sprites directly. Instead, we need to right-click on it and select Create Material Instance. Because we have two background sprites for the trees here, they all use this material, but with different settings. So with two material instances, we can assign the same material to them with different settings. Alright, now we have our first material instance. I have given it the same name as the material with a postfix _inst. Let's save the file and select the tree01. We can go to the viewport and we can see this is the sprite for the tree in the back. We can open the content drawer and drag the instance onto element 0 under material. Alright, let's go to the game level to test. The background is moving when the camera moves, but the movement is weird because the trees are also moving vertically. After doing some tests, I realized I made a mistake in the material. So let's stop the game and go back to the material. Here I'm going to break this connection because for the B input, we should have just given it a 0. You can move the mouse cursor to the empty space and press the number key 1 on the keyboard. This is a shortcut to create a float value. By the way, if you press the number key 2, you can create a vector 2, and the number key 3 is going to create a vector 3 value for you. Alright, let's leave the value of the float 0 and plug it into the B input of the append node. This way, we are not going to change the V value of the UV. Alright, let's go back to the game level to test. And it looks good. Now the trees are moving as the camera moves. We also want to control the speed of the movement, because the trees in the front should be moving faster. So let's stop the game and go back to the material. Let me make some space between the multiply node and the append node. Then we press the 1 key to add a float. Right-click on it, select Convert to Parameter. Let's call the new float parameter speed underscore x. This parameter is going to control how fast the background shifts horizontally. We can give it a default value, and this is going to be the default value for the material instance. Let's make it 0.1. We can even limit the max value for the slider to 1.0. So when you change speed x in an instance later on, you can only drag the slider between 0 and 1. Then let's multiply the speed x by the result of the multiply node. Then we plug the value to the append node. So the background is going to move slower when we set speed x to a smaller number. But you have to apply the change here. Otherwise, the material instance we created is not going to update. Alright, let's open the material instance. You can see we don't have the nodes anymore because this is a compiled material, meaning you cannot change the graph. All you can change is the parameters you created in the graph. So under global scalar parameter values, we have the speed x we just created, and the value is 0.1 by default. This should work. Let's just run the game to test. Great, I think now the speed is better, because these trees are supposed to be far away from the camera. They should be moving very slowly due to the distance. Let's duplicate another material instance for the trees in the front. Right-click on the instance and select Duplicate. I'm just going to change the postfix to _inst2. Alright, let's go to the BP background. Select tree02, which is the tree layer in the front. I want to show you another way to assign the material. You can select the instance2 material first. Then you just hit this icon here. It's going to assign the material that is currently selected in the content drawer. Alright, now this sprite component is using the second material instance. Let's open the second material instance. Enable speedx and set its value to 0.2. This is going to make the trees move faster. But in the actual game, I feel like it's not fast enough, even though the layer is moving faster than the further trees. So let's go back, increase it to 0.35. Alright, now it looks good to me. So here we have the parallax effect in the background. Different values for the speed x creates different feeling in how far away the background layers are from the camera. For now, I feel like this is working for me, but you can tweak the values for speed x to see the different effect. Before we wrap up, there is one more thing I want to point out. Let's go to the content drawer and go to the background folder under the asset folder. Let's open this file that starts with 03. It's the sprite file for the tree layer in the back. Let's search for the keyword wrap in the details panel. This setting determines how the texture behaves when it needs to repeat itself due to the change in the UV. The default setting is wrap for both x and y axis. And this is exactly what we want for here. But I also want to show you the effect of another option. So let's change the x-axis to clamp. Then we save the file and go back to the first material instance. Let's increase speedx to 10 so the background moves faster. Alright, let's see what is going to happen. We can see here when the UV repeats itself, the sprite texture is clamped. Previously it made a loop because it was wrapped. This setting is going to be very useful for the background layer we are going to create in the next lecture. For now, I just want you to know that there is this option that determines how the sprite texture repeats itself. Let's go back and reset the x-axis back to wrap, then save the files. Now we move the player to see what is going to happen. The sprite just repeats itself over and over again. And this is what we want in this case. Alright, let's go back to the first material instance and decrease speedx back to 0.1. Save the file and run the game to test. Alright, the speed is back to normal. Let's wrap up.